Hey everybody. Today we're solving some exponential equations. Most exponential equations are solved using two fundamental properties. First of all, the one-to-one property that says if you have two equal exponential functions with the same base, then the exponent has to be the same as well. The second property is the inverse property, basically saying that the function b to the x can be undone with the function log base b. Logarithms and exponential functions undo one another. Here's a very simple example. E to the 3x plus 2 equals e to the 1 minus x. So this one's solved using that one-to-one property. We have the same base on both sides. So in fact, 3x plus 2 has to equal 1 minus x. Now we just have a basic two-step equation to solve. We put all the x's on one side, all the constants on the other, divide by that factor of 4 to get x all alone. X is negative a fourth. Okay, let's run through some slightly more complicated problems. We're going to do 3 of them. The first one is 8e to the 0.3x minus 15 equals 804. The idea here is to get the exponential function all alone and then to undo it with a logarithm, in this case a natural logarithm. So I add 15 to both sides, divide by 8, and then take those natural logarithms. Again, e to the x and ln of x undo one another. Natural log means log base e. Natural log of 102.375 is about equal to 4.629. And then I finish this problem just by dividing both sides by 0.3. So I get 15.429, approximately. Problem 2. 7 to the 4x equals 200. So this one I'm going to solve using the cancellation property. I'm going to take log base 7 of both sides to get rid of that 7 to the 4x. The log base 7 and the 7 to the power will cancel each other. On the left, I just get 4x because of that cancellation. And on the right, I get log base 7 of 200 is 2.723 approximately. Dividing both sides by 4, I get the answer. I want to make one quick comment here about log base 7 of 200. More sophisticated calculators and calculating apps will have that functionality, but if you're working on a simple calculator, it can be useful to know the change of base formula, which says that the log base b of x is the natural log of x over the natural log of b. And in fact, that right-hand side, that natural logarithm, can be replaced with any base logarithm that you like. For instance, log base 10 of x over log base 10 of b. So in this case, log base 7 of 200 is the natural log of 200 over the natural log of 7. And you can do that in just about any calculator. Problem 3. 6 to the 2x plus 1 equals 5 to the x minus 1. Okay, here we can't just use the one-to-one property that like we did on the first warm-up problem because the bases are different on both sides. Instead, we have to rely on some properties of logarithms to solve this one. I'm going to take the natural log of both sides and then use the fact that the natural log of something to a power is the power times the natural log of the thing. So here I get 2x plus 1 times the natural log of 6 equals x minus 1 times the natural log of 5. Now, this looks ugly and intimidating until you remind yourself that the natural log of 6 and the natural log of 5 are both just numbers. So if we were to replace them with like 4 and 7, for instance, we would know just how to solve this. And really, we're going to follow that exact same procedure, as if natural log of 6 and natural log of 5 were replaced with just integer constants. I distribute through to get 2ln6 times x plus ln6 equals ln 5 times x minus ln 5. I collect all the x's on one side and all the constant terms on the other. Factor out that x from the left. And then finally, divide through. Overall, I get negative ln 5 minus ln 6 over 2ln 6 minus ln 5. If I put those values into my calculator, I get x is about negative 1.723.